Hi guys, so I've had a request for section 9L, question number 6, which is this one. Total surface area of a closed cylinder is 5,000 centimeters squared. Find the dimensions of the cylinder that will maximize the volume. All right, so I'm going to kind of give you a process, a thought pattern to go through this, and hopefully you'll be able to apply this in different situations. So the first thing I'm going to do, the question actually says find the dimensions of the cylinder that will maximize volume. So I know I'm going to need to deal with volume. So how do I find volume of a cylinder? Well, let's see. I've got a cylinder. Okay, so a cylinder is just a prism that has a circle base, right? And so to get the volume, it's going to be the area of this base times the height. Okay, so that's this area right here, and then that slice is going to be multiplied by the height so that it goes all the way down. So you know how to get the volume. Now, the area up there is going to depend on, of course, the radius. Okay, the radius of that circle that's up on the top. Okay, so that area, being the area of a circle, is going to be equal to pi r squared. So what I have now is I have that the volume equals pi r squared h. All right, now I don't have r or h, and I'm trying to maximize the volume. So what I'm going to do here is I need another equation. I got too many variables right now. So I'm going to go back to the other part of the question that says the total surface area is 5,000 centimeters squared. So how do I get the surface area of a cylinder? Well, I've got the top circle here, right, which was A, and the bottom circle there, which is A. And so I'm going to have pi r squared. That's that A again. But then there's two of them. So 2 times pi r squared. That's going to be added to the area of the part going around. Okay, now the area of the part going around, that's actually just a rectangle. Remember when we did maps, nets earlier in the year? It's two circles, which we got those two areas already, and then it's a rectangle that's been wrapped around the cylinder here. The length of that is the same as how far it is around one of those circles, which is the circumference of a circle, 2 pi r. So that's how long this is from here to here, because it has to wrap all the way around the circle. So that's 2 pi r, and of course the length of this side is whatever this height is, all right? So in other words, this rectangle right here has an area of 2 pi r times h, okay? So that is the total surface area, which is 5,000 centimeters squared. And we're not going to worry too much about the units right now, but it is 5,000 centimeters squared. So now what I need to do is I need to be able to solve for one of those variables, because remember back in this one right here, the first equation that I had too many variables. I had a v equals pi r squared h. So if I can solve for one of those variables in this equation and then substitute it in over there, then I'll only have the v and one other variable. Okay, now you can solve for either one, but in this equation over here, the surface area equation, the easiest one to isolate is definitely going to be this h here, right? Okay, so the first thing I'm going to do is I'm going to subtract the 2 pi r squared to the other side. So that now I have 2 pi r h equals 5,000 minus 2 pi r squared. And then we'll divide by 2 pi r, so that what we have is that h is equal to 5,000 minus 2 pi r squared over 2 pi r. And so this, we can now substitute for h in this other equation. Okay? And so now I have an equation for volume that is volume equals pi r squared times 5,000 minus 2 pi r squared over 2 pi r. Now, at this point, you could actually put that straight into your calculator, right? If you wanted, the r is going to be your x value and the v is going to be your y value, and you could find the spot on the graph where you get a maximum y value, right? A maximum volume. If you want to do some simplification first, that's fine too, right? We can cancel out this pi, which is on the bottom. We can cancel out, this is an r squared, so we're going to cancel out one of those with this one on the bottom. And so we're now going to have v equals r times 5,000 minus 2 pi r squared over 2. If I divide both these things by 2, I'm going to get 2,500, and I'm going to get, cross that out, and I'm going to distribute the r in there so that I've got v equals 2,500 r minus, multiply the r by this one, and I'm going to get pi r cubed. And so you'll notice that I do just have a cubic here, which we should be able to calculate, find where the maximum value is for v. Okay, so at this point, I think you can finish this on your calculator. The question is find the dimensions. So here you should be able to find, using your calculator, you should be able to find the x value at which you have a maximum v. You should be able to find the maximum v. And once you have the volume and the radius, you should be able to then take both of those together and put them back into this equation right here so that you can solve for the h that you need. All right? And that's it for this question. Good luck, and let me know if you have any more.